Hi guys, this is Worm's Maths Academy. Just remaking this video because for some reason the other one had some funky sounds in it. So um, hopefully this one's better, and I guess I know what I'm doing now. Okay, two objects of mass 5 kilos and 8 kilos are attached by a light and extensible string that passes over a smooth pulley. So no bearing, no bearing, no bearing on the question at all. Because we have no friction. So we've got a normal force. We have got a 5G force downwards, vertically down. We have got an 8G force, and we have got tension in the string. That's it. We don't have friction. I will, however, say that we've got a component of force here. That's going to be 30. So this bit here is going to be 8G sine 30. Okay, so now when we equate our forces, force equals mass times acceleration. So if we look at this component here, we're going to say that we're going downwards because we don't know, but we'll assume we're going downwards. I've got 5G minus T is equal to 5A, mass times acceleration. And then if we look at this component here, I've got T, which would be going that way, so T minus 8G sine 30. Now sine of 30, 1, 2 root 3, it's going to be a half, so it's going to be 4G. That equals our mass times acceleration, so 8A. Okay, then we add those components, we add it together, both equations, because we're going to get rid of the T's. So 5G minus T plus T, they're going to cancel. 5G minus 4G is G. 5A plus 8A is 13A. So therefore, A is G on 13 meters per second squared. Because we chose to go that way, and we got a positive result, we know that the acceleration of the 8 kilo mass, so the 8 kilogram mass accelerates up the plane at G on 13 meters per second squared. Okay, show that 1 plus I is equal to root 2 cis theta. So the magnitude of that is the square root of 1 plus 1, which is root 2. The angle produced is tan theta is our real imaginary component over our real component, so 1 over 1. So theta has to equal pi on 4. That should be a gimme. Therefore, 1 plus I is equal to root 2 cis pi on 4 as required. Okay, root 3 minus I, so that means we go across root 3 down 1. So this angle in here, tan theta, is 1 on root 3, which we know if we draw our special triangle, 1, 2, root 3, it's going to be pi on 6. However, it's negative, so our angle is going to be negative pi on 6, cis, and our length, root 3 squared is 3, 1 squared is 1, add them together we get 4, square root it we get 2. So that's 2 cis pi on 6. So we can say root 3 minus I to the 10 on 1 plus I to the 12 is equal to 2 cis negative pi on 6 to the 10 over 2 square rooted cis pi on 4 to the 12. Of course, we know on top we've got 2 to the power of 10. Cis of negative 10 pi on 6, negative 10 pi on 6 is negative 5 pi on 3, which is the same as pi on 3. So cis pi on 3 over root 2 to the power of 12. That's the same as 2 to the half to the power of 12, so it's 2 to the 6. Cis of 12 pi on 4 is 3 pi, which we know is equivalent to pi. So cis of pi. Then I've got 2 to the 10 on 2 to the 6, which is 2 to the 4. Cis pi on 3, take away pi, is negative 2 pi on 3, which is equal to 16 times cos of negative 2 pi on 3 is, that's in the third quadrant, so it's negative a half, minus, because sine in the third quadrant as well is going to be negative root 3 on 2 I, which is negative 8 I. Oops. And then minus 8 root 3. But that's not an I. I just rubbed it out and put it back again. Okay, so negative 8 minus 8 root 3I. Okay, find the gradient of the curve at the point pi on 6, pi on 6. Give your answer in that form. Okay, so we've got a product rule, and then that's going to be 0. So if we derive that first, we get 4x sine y. Then, if we derive, we get plus 2x squared, and then we've got the derivative of sine y, which is cos of y, dy dx, because we're deriving it with respect to y. Remember, dy of cos of dy dx is equal to I forgot the y, dy at ddx of cos of y, because of the chain rule. So here, if I put a dy dx at the end, I can change that to dy, because we know that dy and dy would cancel each other out, and we get ddx, if you don't remember. Okay, so that's this, plus derive x, we get 1, so I get y, 1y. Derive y, I get 1, so I get plus x dy dx equals 0. Okay, from here, we can say dy dx is equal to negative 4x sine y minus y over, that's that and that. That's going to be divided by 2x squared cos y, and then I've got plus x. Okay, dy dx, given x is pi on 6 and y is pi on 6, is negative 4 times pi on 6, which is negative 2 pi on 3, times sine of pi on 6, 1, 2, root 3. Sine of pi on 6 is a half, so times a half, so I get negative pi on 3, minus pi on 6 over 2 times pi on 6 squared is pi squared on 18, times cos of y, which is root 3 on 2, because cos of pi on 6 is root 3 on 2, plus x, which is pi on 6. Okay, now we've got to clean it up. So pi, if I put that on a 6, that becomes a 2. So I get negative 3 pi on 6, which is negative pi on 2, over, I've got a pi on 6 in both of these cases, 36. So let's take out pi on 6. We're going to be left with pi root 3. No, let's take out a 36. So pi on 36. So here we get pi on 36, which is that, and one of those pi's. So I get root 3 pi and then plus 6. If that makes sense. Because I took the pi out. But I need to... I've got that 6, is that right? 6. Pi and 6. So if I take out pi and 36, I'm going to be left with a 6. Okay, now dividing by pi on 36 is the same as timesing by 36 on pi. So that would cancel with that. And then I've got 36 on 2, so I get negative 18 on root 3, and then pi plus 6. I made a video before and I don't seem to remember getting plus 6, but maybe I did. Have I stuffed it up anywhere in here? We've just got x, that's x divided x. Okay, maybe that's just it. Okay, x and y are independent. The mean and variance of both x is both 2, and so it's mean and variance both 2. What am I thinking? So e of x is 2, var of x is 2, y is 2 and 4, e of y is 2, var of y is 4. So, given that a and b are integers, the values of a and b, if the mean is, okay, so ax plus by, so we're going to get 2a plus 2b is equal to 10, so therefore a plus b is equal to 5. We're also going to get, because it's a variance and it's a 2, I'm going to get 4a squared, no, the a is going to be squared because I bring it out the front, but it's just going to be the variance of x, which is 2. So 2a squared, and then my variance of y, which is 4, 4b squared is equal to 44. So therefore, a squared plus b squared, 2b squared, is equal to 22, 1 and 2. So let's say a is 5 minus b. So therefore, 5 minus b squared plus 2b squared equals 22. 25 minus 10b plus b squared plus 2b squared minus 22 equals 0. So we get 3b squared minus 10b plus 3 is 0. 3b minus 1, b minus 3. That's going to give us minus 10, so b equals 1/3, or b is equal to 3. However, a and b are integers. So a, b, element of z, therefore b is equal to 3, and a must be equal to 2. Okay, number 5, we have to graph this thing. What do we know? We've got x squared minus 4 on the bottom, which is x plus 2x minus 2. So that's going to give us asymptotes at x equals 2 and x equals negative 2. We also know when x equals 0, I'm going to get negative 1/4. When y equals 0, I'm going to get x equals negative 1. So if I put into there, I just get x is negative 1. What else are we going to do? We've got, if I put 1 into it, I'm going to get 2 on -3, so -2/3, so that's going to be going down here. So this will be like that, and then go away. Go away, you stupid thing. Okay, and then that's going to go down like that. We know that that's, I nearly forgot to label that, -1, 0. If x equals 3, we're going to get 4 on 5. 3, we get 4/5. That's about there. Does it have any restriction? No. Okay, so that will be an asymptote, y equals 0. And -3 is going to give me -2 on 5. -3 is -2 on 5. So -2/5, which is about there. That's rubbish. Not the easiest to draw on an iPad. Asymptotes with their equations and the intercepts with their coordinates. So I think I've done everything that's required of me. I think that's it. No points of inflection or anything. √3 pi plus b squared is equal to 10, so therefore a plus b. Okay. Next question. Okay, a particle of mass 2 kilograms moves with under a force with its position vector at any time given by that. Distance is measured in meters and time is measured in seconds. Find the change of momentum in kilogram meters. Momentum is not kilogram meters per second squared, it's just kilogram meters a second. However, let's work out our velocity. R of t, derive sine to get cos, minus sine of t, j, and then plus 2t k. Okay, we want our final velocity, so r of pi, cos of pi, -1, sine of pi, 0, 2 times pi is 2 pi k. We want our initial velocity, cos of pi on 2 is 0, sine of pi on 2 is 1, so we get -j, and then plus pi k. Okay, so our change in our momentum, our initial momentum, our p final is 2 times that, so -2i plus 4 pi k, and our p initial is -2j plus 2 pi k. So our change in momentum is -2i minus 2j, which is plus 2j, and then 4 pi minus 2 pi k, which is just 2 pi k, kilogram meters per second. I'm not even going to give units because it said to give it in a specific unit. We did. Okay, cot of 2x plus a half tan x is equal to a cot x. Use a suitable double angle formula to evaluate the value of a. Okay, cot 2x is cos, nearly forgot them, on the sine, plus 1 on 2, we don't need that one, do we? Tan is sine x on cos x. Okay, we know that cos 2x is cos squared x minus sine squared x. I'm going to get the same denominator by adding here a sine x on the bottom, because I know sine 2x is 2 sine x cos x. So if I want this to be 2 sine x cos x, I've got to add a sine on the top, so plus sine squared x, so they will cancel. Then I end up with cos squared x on 2 sine x cos x, which is cos x on, let's get rid of that, that is a half cos x on sine x, which is 1/2 cot x. So therefore, A is equal to 1/2. Okay, a tank initially holds 16 litres of water in which half a kilo of salt has been dissolved. Pure water then fills a tank at a rate of 5 litres per minute. The mixture stirred constantly flows at a rate of 3 litres per minute. Okay, so our volume is 16 plus 5t minus 3t, which is 16 plus 2t. Inflow of substance is 0 times 5 litres, 0 litres per minute, or whatever, grams per litre, whatever. Don't need that. Outflow is our concentration, which is Q on our volume, which was 16 plus 2t, times our, how much is going out, 3 litres per minute. So therefore, dq dt is equal to 0 minus 3q on 16 plus 2t. That isn't very neat. You'd hope that they could work out what it was though. 16 plus 2t. Okay, solve the dE. Now, one of the key things here, look at that and look at that. So I'm assuming, don't simplify it, leave it together. So I've got dq dt is equal to negative 3q on 16 plus 2t. So from here, we can say 1/3 dq, 1/3 q. Q dq, no, 1 on 3q. Jeez, bit slow on a Friday night. 1 on 3q dq is equal to 1 on 16 plus 2t, but it's negative because I've got to have the negative somewhere. Okay, so here we're going to get 1/3 log e of q is equal to negative 1/2, because if I put a 2 on top, I've got to put a half and a negative 1/2 at the front. Now the top is the derivative of the bottom. So I end up with log e of 16 plus 2t plus c. Let's times our 3 across the other side. Log e of q is equal to negative 3 on 2. Log e of 16 plus 2t plus c, because it's a constant, we don't really care about that 3, it's just still a constant. We could change it to be d. Okay, we know when t equals 0, q equals 1/2. So I get log of 1/2 is equal to negative 3 on 2 log e of 16 plus 2t plus d. Okay, so that's 2 to the negative 1. So we know, I forgot that, because that's 0. So I get 16 plus d. Of course, we know that's log E4. No, we know that that's, let's fix it up. D is equal to negative log E of 2, and then plus, that's going to go up and become the power, so 3 on 2. When I bring it over, it'll become positive. If I square root 16, I get 4, and then cube it, I get 64. 64. So log E of 64. So therefore, D is equal to log E of 32, because 64 divided by 2. Okay, so therefore, log E of Q is equal to log E of 32 minus log E. I'm doing this because I know that it's got to have a negative power. So 16 plus 2t to the power of 2/3. 3 on 2, sorry. Okay, so now we can join this all together, and we can say Q, get rid of that log. When I join these logs together, I'm going to get 32 on 16 plus 2t to the 3 on 2. So A is 32, B is 3, C is 2. Okay, a curve is parametrically given by this. Show the Cartesian equation of the curve is, okay, so x equals sec t, x squared is sec squared t, y is equal to, y squared is equal to square 2, you get 2, and square 2, you get 4, so that's going to be a half of tan squared t. So tan squared t is equal to 2y squared. So therefore, sec squared t, therefore as sec squared t minus tan squared t is equal to 1, x squared minus 2y squared is equal to 1. Okay, find the coordinates of the points of intersection of those two curves. So x squared minus 2, x minus 1 squared is equal to 1. X squared minus 2x squared minus plus 4x minus plus 1 minus 2 minus 1 is 0. Okay, that's going to be negative. So x squared, bring that to the other side, negative 4x plus 3 is equal to 0. So I join them all together and then brought them to the other side to make it positive x squared. X minus 3, x minus 1 equals 0. So x equals 1 or 3. Find the volume of the solid form when the region bounded by the curve, the line is rotated about the x-axis. So we know we've got x minus 1, which goes through 1. So there's 1 point, and the other point is 3. And then that's a hyperbola, which I'm thinking is going to go like that. So it's got to be this area here, and then that's rotated about the axis. So the higher graph is going to be this one. So we can say x squared minus 2y squared equals 1. So y squared is going to be x squared minus 1 on 2. The other one, so that's y of top, and then y squared of bottom is x minus 1 squared. We want it between 0 and 3. No, 1 and 3. So 1 and 3. Okay, y squared, so x squared minus 1 on 2 with a pi at the front because it's volume, minus, let's expand that out, x squared minus 2x plus 1 dx. Okay, now we can join it all together because we've got both of the y squareds separately. Okay, so we get pi 1 to 3. X squared on 2 minus x squared is negative x squared on 2. I've got negative 2x, so 2x. And then I've got minus 1 minus a half is minus 3 on 2 dx, which is pi negative x cubed on 6 plus x squared minus 3x on 2 from 1 to 3, which is pi negative 27 on 6, which is negative 9 on 2, plus 9, minus 9 on 2, that's 0, minus negative 1 on 6, plus 1, negative 3 on 2, common denominator 6, 6, common denominator 6, times it by 3, so I get 9. So I've got minus 1 plus 6 minus plus 5 minus 9 is minus 4 on 6. I've got a minus there. So minus 4 on 6 is plus 4 on 6, which is 2/3. So 2 pi on 3 units cubed for that volume. Okay, I did answer everything else, didn't I? The position vector of a particle moving along a curve is given by that. So x of t, another parametric one, all ends up being x of t is t cubed on 3. Do I have to draw it? Yeah. So dx dt is t squared. Y of t is sine inverse of t plus t root 1 minus t squared. So dy dt, 1 on root 1 minus t squared. Okay, when we derive this, we're going to use a product rule. That times derivative of that times that. So I'm going to get root 1 minus t squared. Now I'm going to put it over a common denominator of root 1 minus t squared. So that'll get rid of the square root on top, because I know I'm going to add them together. 1 minus t squared. Then plus, okay, we're going to multiply that by t, product rule. That's going to be negative 2t, so it's going to be negative 2t on square root 2 root 1 minus t squared. So those 2's will cancel out and that'll become t squared. So we have got 1 plus 1, 2, minus t squared minus 2t squared on root 1 minus t squared. So our distance is 0 to 3 on 4. Dy dt squared. Actually, what can we take out? We can take out a 2 on top. We're left with 1 minus t squared on 1 minus t squared, 1 minus t squared to the half, which is 2 root 1 minus t squared. Okay, so we've got the square root of 2, 1 minus t squared, rooted. So 2 root 1 minus t squared squared plus t squared squared dx, yeah. So t squared squared dt. Okay, so when we square this, we're going to get 0 to 3 on 4, square root. 1 minus t squared is just going to be 1 minus t squared. So we're going to get 4 1 minus t squared, which is 4 minus 4t squared plus t to the 4 dt. That'll factorise 0 to 3 on 4. We know it has to because there's no square root in the answer. T squared minus 2 squared and square rooted dt, which is the same as 0 to 3 on 4 mod t squared minus 2 dt. Now if I've got t squared minus 2, t squared minus 2 is that. It's a pretty bad graph, but oh, bloody hell, I just did it again. Okay, so that's going to be root 2, negative root 2, so it's going to bounce. But we want it between 0 and 3 on 4, so we want this section up here, which is the negative of that. So it's going to be 0 to 3 on 4, negative t squared plus 2 dt. So therefore, A, I'm assuming that's A is negative 1, B is 0, C is 2. I'm sure quite a few kids would have stuffed that up because they wouldn't have gotten mod, they would have just left it as that function. Square root of something squared. Yeah, and then realise that that's got to be positive. So that's exam 1 for Spesh. Hopefully I'll get to do methods part 2 later. Alright, I hope you had good luck and good luck on Monday. See ya.